Good morning children. Welcome back again to YouTube learning. So in our previous videos we have learned about various concepts of work and energy, right? So what all we have learned? We have learned about the concept of work done, then types of mechanical energy, potential energy and kinetic energy, their derivations, mathematical expressions for potential energy and kinetic energy, and some problems also we have solved. So there are some more problems in the textbook. You can attempt those problems so that you will have a better understanding of the concepts of potential and kinetic energies. And apart from that, we have even quoted examples of potential and kinetic energy. Now, after studying about the types of mechanical energy, like when I was telling you about these examples of potential and kinetic energy, for example, if you take, when you stretch the rubber sling of a catapult, then our muscular energy will be stored in the sling of the catapult as potential energy. When you release that sling, what happens? Whatever stone you have kept in that catapult, it will fly away. In that case, the potential energy will be converting into kinetic energy. Suppose you have water stored in a dam. Water stored in a dam, what type of energy it will have? It will have potential energy. Now, when that water starts flowing, suppose there is a dam or a tank, here water is there, it will have potential energy because the water is at rest. When it is made to flow, then water starts flowing, this water gains kinetic energy. Here what is happening means the potential energy will be changing into kinetic energy gradually. So remember that whenever the object is at rest or it is or its configuration is changed, then energy is stored in the form of potential energy. When the same body starts moving, then the potential energy gradually changes to kinetic energy. Okay. Now let us study about the interconversion of energy. Interconversion of energy. So mechanical energy I have told you, potential energy and kinetic energy. Potential energy will be changing into kinetic energy and kinetic energy will be changing into potential energy. So there will be always interconversion of these two energies depending on whether the body is at rest or a body is in motion. Now, the various examples you can quote. I have quoted two examples. Suppose if you take the wind-up spring of an alarm clock, then our muscular energy will be stored in the spring as potential energy. When that alarm clock starts unwinding, then what happens? The potential energy gradually changes to kinetic energy. So here, even water stored in a dam, if you take, potential energy gets converted into kinetic energy as the water starts flowing down that tank through an outlet. Now, let us consider the simple pendulum and see how the potential energy changes to kinetic energy and vice versa. So, in your previous lower classes, you have studied about simple pendulum. What is simple pendulum? Interconversion of energy in a simple pendulum. Now, simple pendulum means we have a rigid support for which a metallic bob is tied by using a frictionless, non-elastic cotton thread, right? This is a thin cotton thread and this thread is used to hang the bob. This bob is made of some metal, so a metallic bob is there, and this setup is called the simple pendulum. Now, this simple pendulum, when it is at rest, we call it as mean position. Suppose if you set the pendulum into oscillations, then what happens? The pendulum starts moving, it starts oscillating either way. In either direction it starts oscillating, right? See, when you set the simple pendulum into oscillation, what happens? Initially the pendulum is at rest. Let us call the rest position as A. When you start oscillating it, then the simple pendulum, its position changes to B and then to C. Right? So you will take this, the bob of the pendulum, and move it to one direction, then release the bob starts moving. So from position A to B, you have taken the bob, and when you release the bob, what happens? This bob starts moving to A, and again from A, it will go up to C and come back to A. Now again it comes to B, back to A, C. Again A, B, A, C. Like that the simple pendulum starts oscillating. Now see here, this is the ground level. This is the original level when the simple pendulum is at rest. It is in rest position. Now, when you take the bob to the position B, then what happens? You can observe that from this position, the bob is raised to a certain height. Here you can observe this position A and this position B, you compare. When the bob is at rest, so this is the standard position for reference. When you move the bob towards B, hold the bob and move it towards B, then you can observe that the height of the bob increases, is it not? Here what is the height? See, this height I will just take it as h. The bob is raised to a certain height, that is h. Okay, and then when I release the bob, what happens? It comes back to A and again go to C. Here also you see the bob will be raised to a certain height h. The bob will be raised to a certain height h. Now, coming to the concept of potential energy, I have told you that as you raise the body from the ground level, what happens to the gravitational potential energy? The gravitational potential energy starts increasing. So if the body is on the ground or on the earth surface, then its potential energy will be zero. As the body is taken to a certain height, see here I am increasing the height of the body. As the height is increased, then what happens? The potential energy of the body also will increase. At this height, the body will have certain potential energy. If I take the body to a greater height, then again its potential energy changes and it will be increased. If I lower the body, of course it will have potential energy, but the potential energy will decrease. Now, here you see, when the bob is at position B, the bob has attained certain height. Is it not? How much height it has attained? It has attained a height h. Now at this position, the bob will have maximum potential energy. So you have taken the bob to position B and holding the bob at position B. When you are holding, its velocity is 0. If the velocity is 0, then what happens? The kinetic energy becomes 0. But due to the height, it will have maximum potential energy. And the kinetic energy will be minimum. Minimum kinetic energy. Or you can tell that kinetic energy will be equal to 0. Kinetic energy will be equal to 0. Why kinetic energy will be equal to 0? Because when you are holding the bob, then what you are doing? The bob is at rest. You have not released the bob. Because the bob is at rest, it will have 0 kinetic energy because velocity becomes 0. But due to the height, the bob will have maximum potential energy. Okay. Now at position A, Now from B, you will release the bob. When you release the bob, what happens? The bob travels to A. The bob travels to A. When it is traveling, the bob will travel with a certain velocity. So at that position, the bob will have maximum kinetic energy. And it will reach A. A is ground level, right? At rest position. So when it reaches A, what is the height? The height is decreasing fully. When the height decreases, what happens to the gravitational potential energy? Potential energy will be equal to 0. Okay. Now, take at position C. At the position C. Now again, the bob will not come to rest at A. A is at a lower height, so the potential energy will decrease. Then again, the bob will not come to rest. It is reaching the position C. When it reaches the position C, again the bob is gaining height, and due to that height, the bob will have maximum potential energy. And when the bob reaches C, momentarily the bob comes to rest. Momentarily means what? For an instant, for a moment, the bob comes to rest. And when the bob comes to rest, its velocity becomes 0. So the kinetic energy will be equal to 0. So this is very important to remember. Okay. So when I move the bob to position B, then I have moved the bob to a height h. Because of this height, the bob will have maximum potential energy, and because the bob is at rest, its velocity is 0, so kinetic energy will be equal to 0. Now at position A, when I release the bob will travel with a certain velocity. Due to that velocity, the bob will attain kinetic energy, and then the kinetic energy will be maximum when it reaches A, but potential energy will be 0 because it has come to the mean position almost momentarily. Then again the bob continues to move to C. Again it has gained some height, so it will have maximum potential energy and minimum kinetic energy. Here, in case of simple pendulum, you can just observe that there is a interconversion of potential energy and kinetic energy. There is interconversion of potential and kinetic energies. So the same body, when it is at positions B and C, it will have maximum potential energy but minimum kinetic energy. But when at A, it will have maximum kinetic energy and minimum potential energy. So here the energy is not getting wasted anywhere. It is just getting converted from one form to the other. Potential energy changes to kinetic energy and vice versa. So what can you conclude by using this example? You can conclude that the energy can be converted from one form to the another, but no energy is getting wasted here, right? No energy is getting wasted. So you can just convert the energy from one form to the other. You cannot create any new energy nor destroy the existing energy, and that is called as law of conservation of energy. Law of conservation of energy. So what is law of conservation of energy? You cannot create any new energy nor destroy the existing energy. But what you can do? You can just convert the energy from one form to the other form. So this example is given in the textbook also. You can go through the textbook and you can note these points also for your reference. Of course, in the diagram which is quite clear in textbook, you can just make a note of these things in your textbook. Now I will just write down what is the statement of conservation of energy. Law of conservation of energy. The total energy of the system if you take this whole universe as a system, then whatever energy is there in this system, that energy always it will remain constant. Energy can neither be created nor destroyed, but can be converted from one form to the other. Okay. So remember, energy can neither be created nor destroyed, but you can convert energy from one form to the other form. Already we have learned that there are various forms of energy. We have light energy, sound energy, atomic energy, is it not, mechanical energy, all these are heat energy, all these are various forms of energy. So in our daily life, what we will be doing? We will be converting energy from one form to the other form only. So nowhere energy is getting wasted. We are just converting energy from one form to the other form. Of course, you might have seen that when I switch on the tube light or fan, then what is happening? Electrical energy is changing to light energy and mechanical energy. So always remember that energy can be converted only, but it cannot be created nor destroyed. So in the next video, we shall learn about the various forms of energy and how you can convert energy from one form to the other form. Thank you, children.